Hi, everyone. Can you guys hear me? Good. All right. Thank you, everyone, for coming today. I know there's a lot going on, so it's great that you guys stopped by for this. We're going to talk about the impact of robotic umpires in Major League Baseball. I'm presenting on the behalf of a couple of my fellow co-authors, John Palomini and James Zahn today. So we're grateful to be here, and hopefully you guys find this interesting. So just a quick overview. We're going to talk about the inspiration. So why do we care about, the robotic umpires in Major League Baseball? Talk about where we got our data from, talk about the data a little bit, go into some methods, and then look at the results, and then go into the discussion and impact. So what this stuff really means that we came up with. And then just talk a little bit about the future work, and then hopefully we'll have some time for some questions at the end. It's always great to get some feedback from you guys. So to start, we'll start with the inspiration. I'm going to share a video with you guys. It's a Manny Machado at bat from 2015. And in our data set, it was the one of the most missed call at-bats for the umpires. So I'm going to share it with you guys, and on the left here is our strike zone, and on the right are the actual pitches. So you see there, first pitch is a ball, and they called it correctly. Our next pitch here is a ball, but was called a strike. This pitch here was a strike, as we see, and it was called a ball. So same thing there. So the count's 3-1 currently. It should not be 3-1. He thought he got walked, and it was a strike. And then finally, he walked. So ultimately, Machado did earn his walk, and he was awarded the base. But as you saw through the video, almost every pitch was inaccurately called in this at-bat. I think there was only 2 that were correctly called. There was a foul ball in there too, but we didn't want to bother you guys showing you that today. He finally did earn the walk that he deserved. So a little bit further inspiration of why we wanted to do this. So the robotic umpire usage is increasing. So it was used last summer in the Atlantic League. It's a pretty low level of professional baseball. And it's been used a little bit behind the scenes in spring training this year. So we want to know more about how umpires are currently performing and how their performance impacts the game. So look more into this, because as we know, there is a lot of human error in baseball, but how much does this human error actually matter? And then this is important to know for both, at the team level, the league, and individual players. So it's important across the board to really understand more about this, and that is our inspiration for tackling this problem of robotic umpires. So to talk about the data acquisition and description, so we collected data from Kaggle, a very popular site that they post, free to use data sets. It had all pitch data from 2015 to 2018. So that consisted of over 2.8 million pitches. So a lot of data that we had, and it had a ton of features from, pitch location to the outcome of an at-bat to what the pitch was. Everything that you could want was contained in this data set. So we were very lucky that this was posted for us, and we were able to use this. And then we needed to narrow our work more, so we focused only on the pitcher-umpire interaction. So this is only when the umpire is calling the pitch. So it's only called strikes, called balls, and that's it. So if it's a swinging strike, we ignore that because that's not something the umpire actually has to call. That's just a strike. Foul balls taken out, any ball put in play taken out of our analysis. So all of our analysis is based on just pitcher-umpire interactions strictly. And one important note as well is that we use the universal strike zone in determining MisCalls. We'll talk more about this throughout and at the end, but that's just a heads up. So just brief data description here. So on your guys' left, there is just a histogram of the frequency of pitch type. So the big graph is the ball, so that's called balls. The smaller bar is called strikes, so a lot fewer called strikes than called balls. And then the very small bar is balls in the dirt, just because they coded that differently in the data set than balls. So balls and balls in the dirt were two different things. We just had to, we didn't find that out until a little bit later on. And then we also wanted to look at how umpires are doing over the course of the past 4 years, 2015 to 2018. So we looked at each year, and it's roughly the same. I don't know if there's laser on here, but every year there's roughly the same amount of incorrect calls. It's about 10% incorrect, 90% correct for every year. And then we wanted to look further into how are the pitches being missed based on pitch type. So, intuitively you would think probably knuckleball is missed the most out of all pitches. That's a hard pitch to call correctly. It moves a lot. And that's what we found. So that KN on the farthest part of the graph, that's knuckleball, and that was only called correctly roughly 87% of the time. But the interesting thing is the next 4 bars that are the darker colors, they're all fastball pitch variants, meaning it's a sinker, fastball, two-seam fastball, and cutter. So these are all pitches that are thrown at a harder speed, and you would first think that maybe fastballs wouldn't be missed as much just because they're straight. But one reason behind this might be they don't throw fastballs down the middle of the plate. They're trying to hit location. So they're trying to hit a bottom corner or really locate the pitch well, and so that's causing umpires to miss it. So it was an interesting finding just in the data that umpires are missing pitches that are fastballs more than they're missing pitches that are changeup, curveballs, splitters, for example. So that's just an interesting note. And then here's a little bit more description of the data. So we have on our left here a heat map of the percentage of correct calls in each location. So the black box is the strike zone. So as you see, in the corners of the strike zone, a lot of pitches are missed, more than in the other parts. And then right down the middle is getting called correctly almost all the time, as well as the extremes of the outside of the strike zone. So that's just good to see there is some stuff going on in the data. It would be very boring if our analysis was, oh, well, pitch, doesn't matter. Anywhere the pitch is, it's 95% accurate. So it's good to see some, differentiation inside the strike zone and outside of it. And then on the right, here's an interesting thing. There's a metric called the nasty factor. I'm not sure if you guys are familiar with it, but it's based on velocity, pitch break, and location. So even a fastball can have a high nasty factor. It can have a 100 nasty factor if it's like a 99-mile-an-hour fastball located perfectly on the lower half of the strike zone on the corner. So as you see, as the nasty factor increases, the percent of correct calls decreases. So that's what you would think, right? If a pitch is nastier, if it's having more movement, more velocity, if it's better location, it's harder for an umpire to call it accurately. So just to go into the methods part, we want to just go over how we went about determining a metric to decide what is the impact of umpires. So we created a metric that we call RE12. There's an existing metric called RE24, and that's what we present in this table. So RE24 basically gives you a run expectancy for every out and base state. So for example, 0 outs, nobody on base, your run expectancy is 0.461. So what we did to create RE12, which is a run expectancy for each possible count. There's 12 counts, so we call it RE12 instead of what they called RE24. So we would take every at-bat that ends in a 0-0 count. So that means that the ball was put into play on the first pitch, whether it was an out, a home run, a single, whatever. And then we would calculate the RE24 of that at-bat. And we would average that over the course of all at-bats that ended in a 0-0 count. And we did this for each of the 12 counts. And to show what this resulted in, it was a table here. So we see that for each count, we get a run expectancy measure, and only 0-2, 1-2, and 2-2 are counts that they're negative run expectancy. So those you would definitely consider hitters counts, and intuitively about baseball, those are definitely hitters counts. But it's interesting to see that everything else is a positive run expectancy, even something like 0-1, where the pitcher gets ahead. That's still a positive run expectancy for the hitter. So that's an interesting thing. They're behind in the count, but it's still could be a good thing for the hitter. And then we see it gets very high. If the count gets to 3-0, we're up to a .248 run expectancy, which is incredibly high compared to any other count up there. And then we looked at it on average, if 15 calls are missed over the course of a game, that could lead to 1 additional run for the team. So it's about .065 runs per missed pitch. So you would think maybe 1 pitch is not a big deal, but when this stuff aggregates over the course of a game, it can add up to a big impact. And a lot of baseball games are decided by as little as 1 run. So this is a huge impact across the board. And then something that needs to be discussed too is that we saw in the beginning. There are a lot more pitches that are called balls than strikes. And then we see it even more here, that pitches that were miscalled balls and miscalled strikes. And this is what kind of skews our metric. So the average run expectancy of a miscalled ball is plus .12. For a miscalled strike, it's negative .1. So if these 2 bars on our graph are equal, if umpires were missing at about the same rate for balls and strikes, there would be almost no impact. But the fact that they're missing balls much more often, it's helping the batters a lot more. So that's a pretty interesting thing that we find in our analysis, just this unequal distribution of missed calls. So we wanted to look at it further, though, and we wanted to look at individual pitchers. So these are examples of pitchers, Garrett Cole and Justin Verlander, some of the top pitchers in the game. And the gray line on the graph is the league average. So that's the league average of percent of pitches called in the pitcher's favor. So you see for these 2 pitchers, their bars are very close to league average. So they're not really getting any extra help that anybody else in the league is getting. It's right around average. So you might think Cole and Verlander, if robotic umpires were put into play, would remain very valuable because they are not relying on pitches to be miscalled in their favor. So that's a big thing that we found with Cole and Verlander. And it's something you would find in other pitchers too, but these were some of the top pitchers, so we want to look at them. And then if we look at Masahiro Tanaka and Clayton Kershaw, we see that they are well above league average in terms of the percent of pitches they're getting called in their favor. For example, specifically in the last couple of 2018-2017, Kershaw is getting above 6% of pitches called in his favor, which is about twice that of the league average. So that's a huge number of pitches that he's getting in his benefit. Maybe this is because his name's Kershaw, and everyone thinks Kershaw is a great pitcher, and he has a lot of respect around the league. But maybe it's not. Maybe it's something due to that nasty factor we showed earlier. Maybe a lot of his pitches are really nasty, and umpires are having a tough time calling them what they actually are. So that's one really interesting case. And it's a similar story with Tanaka. I watch a lot of his games as I'm a Yankees fan, and he's got a great splitter that's pretty good, but maybe that's really difficult for umpires to call correctly all the time. And then we see some more interesting patterns that aren't just, they always get above league average, or they're always at league average or below league average. So for example, we'll walk through Dallas Keuchel first. So his best recent years were in 2015 and 2017. 2015, he was Cy Young winner. He was an All-Star. 2017, he was an All-Star. So you see he's the darker bar on this graph. He's well above league average in both 2015, the first group, and then the third group in 2017. So in these years, when he's performing his best, he was also getting the most calls in his favor. So we're not implying directly, if you get more calls in your favor, you're going to have the best years of your career. But it must have played an impact into why he was able to perform so highly. If he's getting more pitches called in his favor, it's going to be a lot easier for him to get deeper into games, get outs quicker, and just everything like that. We see a similar phenomenon with Felix Hernandez, who's been not very good the past few years, but in 2015, he was 7th in Cy Young, and he was an All-Star. So, and in that year, which is the first group, in the green bar, he was well above league average, and since then, he's been at or below league average. So again, maybe this decrease in the percent of pitches he's getting in his favor is hurting him. Oh, sorry about that. So we wanted to move on to discussion and impact just to talk more about what this really means to the game of baseball. So for catchers, pitch framing is now irrelevant if robotic umpires are in play. It doesn't matter how well they can present the ball to the umpire, so their value decreases. A huge thing right now is catcher pitch framing, and with robotic umpires, it's just gone. Hitters that are currently getting more missed calls will need to adjust their games. One batter that comes to mind is Joey Votto. He's always known as having a great eye, and maybe that's true, or maybe it's based on reputation, similar to what we saw with Kershaw. And then some pitchers become more valuable, like Cole and Verlander, as I showed earlier. They aren't really relying on more missed calls in their favor. So these pitchers would remain valuable, even with robotic umpires, but some of the other top pitchers might not be as valuable as they once were. And then we want to give a kind of like a case study on this. So back to the Dallas Keuchel example. In 2017, he had a 2.90 ERA, he pitched 145 innings, and he had 3% more incorrectly called pitches than the league average. So he was getting quite a bit more in his favor. However, over the course of the season, if robotic umpires were implemented, over 130 of his pitches would have been balls that were originally called strikes. So this would have some sort of impact on him. It's hard to put an exact value, but you could imagine his ERA is going to increase. You could imagine that his value is just going to decrease because he's not getting as many calls in his favor. So he would need to make these adjustments more than maybe other pitchers in the game would, just because he's not getting these calls like he once was if robotic umpires were in use. And then we just want to take a minute to talk about some future work. So one big thing I mentioned earlier was that we use a standard strike zone. So that could be a problem because, batters are different heights. Jose Altuve, Aaron Judge, the two different ends of the spectrum, right? So just adjusting the strike zone for each batter to have a more consistent, correct call strike zone to compare it to. Also, inspecting the impact on batters. So we didn't really focus on batters much. We really did focus much more on the pitcher side of things. So just looking more at the batter's perspective and how much it would really impact them. And then finally, something that came to mind was how do pitchers adapt to different umpire strike zones? So that's something we could look at now because different umpires have different strike zones, and it would be interesting to see, like if a pitcher goes into a game and knows, hey, this guy's going to squeeze me a little bit more, this guy's going to have a bigger strike zone, how does the pitcher perform differently in those different cases with those different umpires? So overall, there's a great amount of future work that can be done. I think we just started to scratch the surface on this work, and we're happy with our initial results, but there's definitely plenty more work to be done, and it's something we really hope to continue moving forward. So thank you guys. Thank you everyone for coming, for sharing this time with us. We really appreciate it. Maybe that's what a robotic umpire would look like. We're not sure. But yeah, if you guys have any questions, I'd be happy to answer some. Sure.
That you had said most of the calls were on the edges.
That
were missed. How does that factor in then to historical and institutional knowledge that's agreed upon between batter, pitcher, and the umpire? In the sense that there was an article written in the league about a pitch was thrown, everyone thought it was a strike, but it was called a ball or vice versa. But the pitcher, the hitter, and the umpire all agreed that, no, we know this is a strike. How do you factor that in as we transition to more technology up against institutional knowledge that's agreed upon?
Yeah, I think that's
in some cases not agreed upon.
Yeah, I think that's a great point. That is something that's kind of agreed upon now. What is a strike, what's not a strike? People will say letters is a strike, but then it's not actually called, right? But if it's an automatic or robot umpire, maybe that would be a strike, and it would be a huge change in the game. Batters would be upset, if they're getting called a strike at the letters, they would be furious because that's not actually a strike anymore. Even though in the rule book, it might be a strike. So I think it would have great impact on that sort of thing where it was like changing just the dynamics of what somebody conceptualizes as a strike versus what actually is a strike. Go ahead.
2 questions.
Sure.
The first one, were you guys doing a 2D or a 3D plate for your automatic strikes?
2D, yeah.
2D?
We had 2 dimensions on the data set. They provided, just 2 dimensions for that.
Okay. And then when you're comparing Kershaw and Tanaka versus Cole and Verlander, were you trying to neutralize different things like catchers? So if they have a better framing catcher and they don't, to kind of see why were some of the numbers skewing out? Did you take steps like that?
Sure. So we didn't look at that, but that'd be a great point because I know Tanaka's catcher is not very good. Sanchez, he's not really known as a great defensive catcher. Offensively, he's great, but I think that's a great point is to neutralize for that sort of different catcher. But we are looking at it just on pitch location that we base if it's a missed call or not. So that might be kind of taken out of the equation a little bit because it's not all about how the umpire is seeing the pitch. It's about where it actually crossed the plate that we're determining if it's actually a ball or a strike, but that could definitely influence what the umpire is calling in that term. So yeah, that's definitely a great point. Thank you.
When you were looking at the zones in which the umpires were more likely to get a call right or wrong, were you looking at like the same spot for righty and lefty hitters, or when they were would an inside pitch to a righty be the same spot as an outside pitch to a lefty?
So that heat map I showed earlier, I think that's what you're referring to. That's not based on righty or lefty because the data is based strictly on just an X and Y plane. So it already is kind of neutralized. It doesn't matter which side the hitter is on. But yeah, okay. Thank you. Great point.
I was curious if you had any rankings on how good or bad certain umpires are. Like if you looked inside.
Yeah. So
is Angel Hernandez terrible? Are there other umpires that are better?
Yeah. I think that's a great point. We didn't look too much at specifically umpires because we wanted to focus more on what would happen if robotic umpires were put into play, but that's a great point. And I think there's been some research done on that, and I know also umpires throughout the season get feedback on how well they're doing. And there was an interesting article one of my teammates told me about was that there's research that's been done on the difference between older and younger umpires, and younger umpires are having a much more consistent and accurate strike zone than the older umpires. So yeah, there's a lot of discrepancy across like just different umpires. So yeah.
So for the pitchers that you mentioned specifically, you talked about how many of their pitches were miscalled to be strikes. Do they have a proportional rate of pitches that are miscalled to be balls?
I'm not sure. That's a great question, though. It would be good to look at the other way as well, but we really wanted to see how much some pitchers are benefiting, not how much they're getting hurt. But yeah, maybe it neutralizes and it doesn't matter as much. So I think that's a great to look at it the other way around as well, for sure.
All right, last question.
Sure.
Hi, I know you looked at a few years and you showed a few different pitchers and some were consistently overperforming in the stat and underperforming. Have you looked at year-to-year predictive value of this?
What was that? Year-to-year predictive value?
Yeah, like Clayton Kershaw we saw was benefited from these incorrect calls year after year. That could just be you looked at 50 pitchers and pulled them out. Do you know how predictive like this current year will be for the next year?
We didn't look at that, but I think that's something that you could kind of look at using our past data that we have now to predict maybe this year how greatly they'll benefit from umpires. But as we showed, maybe I can go back to it with the Felix Hernandez case. He doesn't look like there's a really great trend there. It was really high and then it went really down below average. So I think there was just a lot of differentiation from year to year on this metric. Yeah.
All right, thank you very much. Please give it up for Luke.